So in this video, we are going to start with logarithm. What the definition for it is? Every positive real number, every positive real number, if we take it as suppose capital N, can be expressed as in exponential form as capital N equals to a to the power x. For example, if we take 49, so 49 we can write it as 7 scale, where a is also a positive real different than unity. Okay, it's also a real number different than unity and is called the base, and x is called the exponent. Okay, so here a is the base and x is the exponent. We can write this as log. In logarithmic form, we can write it as log n to the base a. Base will be written here like this is equal to x. Hence, if we see these two relations, these are like capital N equals to a per x and x is equals to log n to the base a, where n is positive, n is greater than 0, a is also positive, and a is not equal to 1. These are the three conditions that we have to check. So from here we can say that hence logarithmic hence logarithm of a number to some base is the exponent by which the base must be raised in order to get the number. Logarithm of 0 does not exist. and logarithm of negative reals are not defined. So we will see some examples now after this illustrations. First, suppose we have to find the value of first one log 27 to the base 81. So we will assume this number suppose as x. So log 27 to the base 81 equal to x. So from here we can write it as what what is the meaning of this? Means if we are raising the x power to the base a, we will get 27. So from here we can write it as 81 to the power x is equal to 27. 81 can be written as 3 power 4 to the power x is equal to 3 power 3. So 3 power 4x is equal to 3 power 3, which implies 4x equal to 3, and which further implies x is equal to 3 by 4. So in this way we will solve the questions. Second example is log 100 to the base 10 is equal to x. So from here we can write it as 10 to the power x. 10 power x is equal to 100. So which implies 10 power x is equal to 100 can be written as 10 square. So from here, if we compare, yes, we can see the base are same. So we can compare the powers. X value will be 2. Okay. And next one is third one. If we take one more example here. Log 9 square root of 3 to the base 1 by 3 is equal to x. So from here we can write it as 9 square root of 3 equal to 1 by 3 power x, which is equal to 1 by 1 power x by 3 power x, which is 1 by 3 power x. So from here we can write 3 power minus x. 9 root 3 can be written as 3 into 3 into root 3 can be written as 3 power 1 by 2 equals to 3 power minus x. So from here we can see here the power is 1, here also power is 1, here power is 1 by 2, and the bases are same. So if bases are same means we can add the exponents of power. So it will be 1 plus 1 plus 1 by 2, which is equal to 3 power minus x, which implies 3 power 5 by 2 equals to 3 power minus x. So from here, if we compare, then we will get it as x equal to minus 5 by 2. So this is the answer for this question. After that, we will write some note 1. Unity has been excluded from the base of the logarithm as in the case log n to the base 1 will not be possible, and if n equal to 1, then log 1 to the base 1 will have infinitely many solutions. And will not be unique. Which is necessary in the functional notation. Thank you for watching. Please subscribe the channel and like the video.